I'm going to talk in this lesson about function notation and specifically how we plug things into functions. So what we're going to start seeing is y equals this f bracketed x, which we would read as f of x, like of the word of. So if you were to read this, what this thing here is saying is y is a function of x. And you need to be really careful about this, the way that this is written. I wrote down this little example here. If you have a x bracketed x plus 3 written like this, that's actually x multiplied by x plus 3. That's how we would read that and interpret that. We have the same brackets here, and f outside of a thing inside brackets, but it's not multiplication. So it can be a little bit confusing if you haven't worked with this notation too much before, but eventually you'll just kind of become familiar with which contexts are you using this function notation and when you would actually be using this multiplication. So it's a little ambiguous, but usually it's quite clear what's actually intended. So yeah, we'll just go through and describe how we're actually going to use this. So suppose that I'm going to just make up a function here, f of x equals, let's say, x squared minus 5x plus 3. So that's what we would call a quadratic function because it's a quadratic on the right, if you remember, a second degree polynomial. But yeah, it's basically a function. So it's not really much different than writing just y equals x squared minus 5x plus 3. There's a really subtle difference though. And really, to me, the difference is the amount of information that gets retained as you're working through something. And so what we're going to do is just plug some stuff into this. So what we'll do is maybe evaluate f of 1. And so to do that, basically, we just take this x and swap it out for 1. It's a substitution. And so every x in this gets replaced with x equals 1. And we know that when we do a substitution, we should put brackets around that. So 1 squared minus 5 times 1 plus 3. And then we can just clean up this right-hand side. So I'll have 1 minus 5 plus 3. So negative 4 plus 3 is negative 1. So the idea is we have an equation that we started with, this f of x equals x squared minus 5x plus 3. We know that with equations, if we're doing any algebraic operations or like solving things, we always do the same thing to both sides of the equation. That's what we've done here. Every x on the left turned into a 1, so every x on the right turns into a 1. So it's same principle that you probably learned like grade 9-ish. Oh yeah, so we get f of 1 equals negative 1. I'm going to rewrite this just to make it very clear what this statement is saying. It's not f times 1, again, remember. What this is actually stating is the function f evaluated at 1 or you can say x equals 1 is equal to negative 1. Or in other words, when I plug in 1, I get out negative 1, something like that. So this is where the function notation is actually really useful, because if I just used y, what my end statement would be is y equals negative 1. And you actually lose all of the x information in that statement. Whereas this notation actually, at the end of the day, it tells you what the x was that gave you this output of -1. So that's why it's just a slightly more useful notation than just using y's all the time for functions. So let's do another one. Let's evaluate f of 4. It's really going to be the same idea. So I'm just going to turn all of my x's into 4's. So 4 squared minus 5 times 4 plus 3. Is that? I didn't mean for that, but it looks like I might be getting the same thing. 16 minus 20 plus 3. Yeah, it's also -1. I think you'll believe me when I tell you they're not all -1. Like try plugging in 0, you'll see you get 3. But yeah, we also get a f of 4 is -1, so that would be our answer. So just again, to remind you of this, it does not mean f is -1 over 4, right? So we don't do that. We don't divide by 4 because it looks like multiplication. It reads as f evaluated at 4 is -1. So usually people, if they make that mistake, they only make it once or twice, and then eventually it kind of sinks in. So I'm gonna move up a little bit to some slightly more abstract plugins. Okay, let's go with f of how about f of 2c? So now what I'm doing is actually, I'm not plugging in a number, I'm plugging in something that's got another variable to it. But it should be kind of the same idea. All x's get replaced with 2c. So I'm going to have that x there. Again, make sure you use those brackets. But I'll have 2c squared minus 5. Instead of x, I'm going to write 2c and then plus 3. So same idea. And then I'm just going to simplify the right-hand side. So if I do 2c squared, remember that that square is going to get applied to both the 2 and the c. So 2 squared will be 4, and c squared, I can't do any better than c squared. And I can distribute the 5 through to get 10c. All right, it's just a single term in there, and then plus 3. And then those are 3 different terms, the c squared, c, and the constant, so I can't reduce that any further. So we should get, yeah, just this new sort of polynomial in c. All right. Yeah, so a really big use for functions and plugging things into functions. If you've done any physics, you've probably seen a lot of functions of like the height of a ball over time. If you throw it in the air and there's a gravitational constant that kind of should have something to do with a coefficient out front of the x squared. And there's all sorts of exponential functions and all kinds of functions. Pretty much everything that we try to describe in nature, every phenomenon with numbers, we usually try to describe it as a function. So it is a super useful thing to be able to know and work with. Now, I think most of you guys are probably going to take calculus, and in calculus, to build up a lot of language, something that you'll often see taking place is having to plug in a slightly more complicated thing into a function. What you often have to plug in is something like an x plus h, or maybe like an x plus 1 or an x plus 2 or something like that. This one the x plus h is what you'll often see in calculus. I'm going to do a slightly easier one, I think, right now, and just do like maybe x plus 2, and we'll see how this works out. So again, we're plugging in algebra for x. Like the last one we plugged in 2c. It wasn't a number. I couldn't reduce it to a number. I just plugged algebra in, and it's the same idea here. Exact same thing. All of my x's become this bracketed x plus 2. All of them. So same idea. X becomes x plus 2. And you do need to make sure that you have those brackets, otherwise the whole inside won't be inside of this x. The whole inside won't be inside that square like it's supposed to be. So make sure you've got those brackets every single time. Minus 5, again, x becomes x plus 2. This one, I think, tends to create a few more problems with people because instead of swapping x out for this whole new variable c like I did last time, what we're doing is swapping it out for a different x expression. So it's almost like I'm saying x is x plus 2, but that's never true. X can't be x plus 2. That's a logical fallacy. That's not possible. But I'm not saying they're equal. I'm saying turn it into this new thing. Just change it. You're changing it. That's allowed. As long as the left side and the right side are changed equally. That's the way equations work. Right, so we've got all our x plus 2's. I definitely forgot something there, so I'm going to put that square that I missed so that it looks exactly like the line above, except x's are x plus 2's. Same as before, I can just clean it up a little bit. That x plus 2 squared, remember how to do that. Just a little review. It's not x squared plus 2 squared. You can FOIL it out if you don't remember the squaring formula. You can just FOIL the thing out. So the firsts will be x squared. The outsides will be x and 2. The insides, x and 2, so 2x, and the lasts, 2 and 2 is 4. So we'd have x squared plus 4x plus 4, right? Don't forget that middle term. Yeah, so just be careful of this. So I'll get x squared plus 4x plus 4. Now I can distribute that 5 through the two terms, so minus 5x minus 10, and then plus 3. Yeah, so now we'll just clean it up. We have a couple of like terms. So I've got my x squared. There's 4x and minus 5x, so minus x, and then 4 minus 10 is negative 6, plus 3 is negative 3, and that should be our new function. So what we've done is we've created a new function from an old function, basically by what we'll actually see later is just a sort of shift of the variable x to become x plus 2. And so that's going to be our output. You'll see in some of the homework, it might get a little bit more complicated with like an h there instead. And then you'll have something called a difference quotient, where you have to take this thing and put it into a bigger expression. I've got some examples of those in the posted written notes if you want to go through those. They're just a little bit time consuming, but it is pretty much just exactly what we did here, but with an h. So there's not too much to it. Okay, so that should wrap up plugging things into functions. That's about as hard as it gets. And then we'll sort of see what this actually does later. So that'll be the end of this one.